The Pacific island nation of Tonga suffered significant damage in Saturday's volcanic eruption. The largest underwater volcano, presently the deadliest volcano hiding in the Pacific Ocean, has violently cracked open the earth. Scientists speculate that the sheer ferocity of this massive eruption poses a catastrophic and far-reaching consequence that far surpasses the extent of destruction of any land volcano. Working over time to estimate the possible magnitude of the eruption and seek ways to prevent an impending disaster, scientists are left with two questions: how massive would this eruption be, and how drastic could its impact be? In today's video, we will unravel the details, discussing the changes and possible impact of this appalling volcano. The ash fall has been significant, and the tsunami waves have been destructive, but we don't know the extent of the damage. Tonga's capital, Nuku'alofa, is covered in a thick film of volcanic dust. This is because the largest underwater volcano in the world is on the verge of erupting. The risk of a sudden eruption has just increased by 360%. This means that it has the volcanic explosivity index of 6 eruptions, and it would be the most disastrous eruption seen since Krakatoa in the 19th century, with the potential to destroy the entire world. Massive volcanic activities were considered a thing of the past because major eruptions were easily contained. However, recent eruptions have shaken everyone at their core. The Hunga Tonga Hunga Ha'apai volcano is one of the most active and deadly volcanoes in the South Pacific, residing along the Kermadec Tonga Ridge, a dynamic geological feature formed by the convergence of the Pacific Plate and the Indo-Australian Plate. This convergence forms a long chain of islands and volcanoes, creating a vast area existing under the ocean's surface. Its predominantly submerged state characterizes Hunga Tonga Hunga Ha'apai. Only two small volcanic islands, Hunga Tonga and Hunga Ha'apai, are above the waterline as silent markers of the volcanic activity. Below, these islands stand as the remnants of the once formidable calderas, shaping its landscape with deposits from previous volcanic eruptions dating back to 11.8 CE. But now, the volcano's risk of sudden eruption has just increased, all because the 2021 to 2022 eruptions were much bigger and more powerful than anyone could have imagined. Before discussing the possible impact of the Hunga Tonga eruption, let's take a moment to talk about some of the most catastrophic volcanoes that have ever erupted. On December 20, 2021, the Hunga Tonga Hunga Ha'apai volcano erupted, causing significant ash fall and destructive tsunami waves. The eruption was so powerful that people could hear explosions from 110 miles away, and it continued raging until about 2 a.m. on December 21. After this first eruption, satellite pictures on December 25 showed that the island had gotten bigger, as expected from past eruptions. The volcano gradually became less active, and on January 11, it was declared dormant. However, on January 14, the volcano woke up again and sent ash 12 miles into the air. The next day, a stronger eruption occurred, surpassing the one on December 20. This time, the ash cloud reached an incredible 36 miles, setting a record for how high a vapor plume from a volcano can go. The eruption had a big and widespread impact, with people hearing the boom in Tonga, Fiji, New Zealand, Australia, and even Alaska, 6,200 miles away from the eruption site. The shock waves were felt in the United Kingdom. The eruption could be compared to the force of a hydrogen bomb, causing tsunami waves as high as 148 feet on Tonga's Tafua Island and 56 feet on Tonga Tapu. The volcano released water vapor equal to 58,000 swimming pools, likely affecting the planet's climate and causing temporary global warming. The eruption set a record for the highest volcano plume, projecting ash 36 miles into the atmosphere. It also created atmospheric waves that circled the globe at 720 miles per hour. After the eruption, researchers saw the damage, confirming the study's findings. The landscape showed the eruption's power, with downed trees and vegetation along the coast. On January 15, the eruption had different events, from small to explosive. Witnesses heard 2 initial blasts and 2 louder booms that caused the first damaging tsunami waves. The 5th blast was the most powerful, similar to the biggest nuclear tests by the United States. It displaced seawater, forming a huge local tsunami in the blast center. A minute after the blast, the wave was 85 meters high as it reached Tonga's Tofua Island, and it was still 45 meters tall. The study found that shallower waters along the shore helped lessen the tsunami's power, and its energy decreased as it moved along the seafloor. Regarding the impact of this eruption, there is limited information about the damage and how many people were affected in Tonga. An undersea cable was damaged, hindering communication and rescue efforts. Sky News reported with videos that waves were hitting Tonga's coastal areas, and Atata, a small island near the capital, was reportedly submerged underwater. Rescue operations were made, and most of the island was wiped out. There were reports of residents struggling to breathe due to ash. The New Zealand Defence Force called the damage catastrophic, with Mango Island left in ruins, Nuku Island suffering significant damage, and Whanua Island left with only 2 buildings still standing. The west coast of Tongatapu was hit hard, with 21 homes destroyed and 35 more severely damaged. The eruption ravaged the waterfront of Nuku'alofa, with reports of missing individuals adding to the devastation. As relief efforts were sent to the region, the true extent of the damage in Tonga was still unknown. The eruption had caused severe damage to the Tonga cable system, disrupting communication and hindering rescue efforts. Repair crews faced numerous challenges due to ongoing volcanic activity, and it wasn't until later that limited satellite connectivity was established. A cable repair ship arrived in Tonga on January 30, and the tireless crew worked until February 22 to repair the damaged cable. The eruption's impact was not limited to Tonga. Other regions, such as Fiji, Japan, Hawaii, and Peru, experienced casualties, material damage, and an oil spill. The disruption of flights in the surrounding region due to volcanic ash added to the chaos and devastation caused by this natural disaster. The World Bank estimated the total damage in Tonga at a staggering $90.4 million, significantly impacting the country's GDP, accounting for 18.55% of its total. The global fallout for this massive eruption happened because water got into the volcano's hot magma, causing a steam eruption. Initially, four blasts broke the rocks, letting a lot of water into the magma chamber. Though the study could not state the main cause of the volcano, scientists think that a magma hammer effect caused it. The magma possibly had turbulence and was moving up and down like a hammer, causing the eruption. The seismic record also showed a strange pressure drop during the eruption, which is not typical for volcanic eruptions. The eruption began in December, and because the exact cause is known, these volcanoes are unpredictable. They can suddenly become active as magma moves through their pathways, and anything can happen in those pathways. Dan Slayback, who helped with the study, mentioned how surprising it is for volcanic activity as big as this to happen suddenly with almost no warning. There were smaller eruptions before January 15, but scientists were not expecting the following eruption. Its size surprised everyone, and Slayback stated that it was probably a 1 in 500-year event for the region, maybe even the whole world. The study on the 2021 to 2022 eruptions said that the eruption could have endangered more people without the quick response from the local community and tourists that helped evacuate people. The eruptions are now compared to Krakatoa, the most destructive eruption in modern man's history. The 1883 Krakatoa eruption happened between the Java and Sumatra Islands in Indonesia. Krakatoa is a stratovolcano, built up by the accumulation and collapse of layers of lava, ash, and other materials from eruptions over time. Before the huge 1883 explosion, Krakatoa had smaller eruptions and trembles, indicating its activity. Volcanoes activate whenever hot liquid magma moves under the Earth's surface. As magma moves up, it can break rocks and make waves in the ground, measured with seismographs. For Krakatoa, the waves told experts that magma was pushing towards the surface. By August 1883, the pressure inside the volcano had reached a critical point, and it erupted on May 20, 1883. The eruption lasted until October 21, 1883, and its kind, a Plinian eruption, is famous for making a tall column of ash and gases. The eruption was so big that the island collapsed, causing huge tsunamis. The death toll was estimated to be between 36,417 and 120,000. The island where Krakatoa was is now a big hole in the sea, and over time a new island grew, filling the initial hole caused by new volcanic activities underwater. This new island is called Anak Krakatoa, a child of Krakatoa, and it is still an active volcano today. Given how massive the Hunga Tonga Hunga Ha'apai volcano eruption would likely be, one might wonder if it would be the last time the volcano erupts. Well, not exactly. Even though the eruptions in 2021 and 2022 seemed sudden, the volcano wasn't completely inactive. This volcano is known for being very unpredictable and has shown signs of activity before. From 2014 to 2015, there was an eruption under the sea in this area, and it was a significant event for the ongoing geological processes shaping the Pacific region. The eruption happened from mid-2014 to January 2015, occurring beneath the ocean's surface. So, what we saw on the surface was just a small part of what was happening underwater. The volcanic activity led to the buildup of volcanic materials, slowly creating a new landmass that eventually broke through the ocean's surface, forming the visible island near Hunga Tonga. The Hunga Tonga Hunga Ha'apai volcano is in the same league as stratovolcanoes, shield volcanoes, and cinder cone volcanoes. How destructive can these volcanoes be? Shield volcanoes are like the gentle giants of volcanoes, with wide, low shapes and fluid lava that flows easily, creating broad slopes. Famous shield volcanoes, like Mount Loa and Kilauea in Hawaii, have shaped the landscape for a long time. However, in 2018, Kilauea had a huge and unexpected eruption, a fissure eruption with cracks opening up in the ground. The eruption destroyed homes, buried neighborhoods in lava, and caused major damage. This eruption surprised scientists because it was so unexpected, highlighting the volatile and dangerous nature of shield volcanoes. On the other hand, cinder cone volcanoes are smaller but potent members of the volcanic family, with steep cone-shaped mountains resulting from explosive eruptions driven by the release of gas and ash. Unlike shield volcanoes, cinder cone volcanoes have a more distinct cone-like shape. Famous examples include Paracutin in Mexico, which emerged from a cornfield in just 9 years, covering the town of San Juan Paringaricutiro with layers of lava. Stratovolcanoes, known for their towering heights, steep slopes, and distinct composition with alternating layers of lava, ash, and other volcanic materials, are nicknamed for their cake-like layers. Mount St. Helens and Mount Fuji are examples of stratovolcanoes that provide crucial clues about their past and the potential dangers they pose. When stratovolcanoes erupt, they shoot ash and debris high up in the sky, causing widespread damage. Mount St. Helens erupted in 1980, tragically taking 57 lives and reshaping the land with a powerful explosion. Mount Fuji, Japan's tallest mountain, last erupted in 1707, leaving a mark on Japan's history with ash covering nearby towns, threatening crops, and causing food shortages and economic troubles. Historically, volcanic eruptions can have a significant impact on the world. The volcanic winter of 536 was a global chill with darkness and freezing temperatures lasting for years. The exact location of the eruption is unknown, but its effects were felt as far away as China and the Middle East, causing weird weather. The volcanic winter of 536 released substances into the air that blocked sunlight, making the Earth cooler. European summers got much colder, almost 2.5 degrees Celsius below normal, leading to widespread famine and disease, including the plague of Justinian, which took the lives of 25 to 50 million people. Considering the massive eruption of the Hunga Tonga Hunga Ha'apai volcano, its impact is severe, burying sea animals, ruining habitats, and putting the land's fertility in danger. This affects Tonga and has wider implications on crops and fish, leading to food shortages and financial losses. The eruption adds to Tonga's challenges from the pandemic, causing destruction, displacing people, and disrupting businesses. The unexpected nature of this event has global implications, raising concerns about the vulnerability of Hunga Tonga to another significant eruption soon. If it happens, it could bring back past catastrophic times, with famines, diseases, and other challenges resurfacing. overcoming them might be even harder this time. In conclusion, the pending eruption of the Hunga Tonga Hunga Ha'apai volcano is a serious concern, and its potential impact on humanity and the planet is significant. The unpredictable nature of volcanic activity, coupled with the historical precedents of devastating eruptions, raises questions about our ability to mitigate and cope with such natural disasters. The ongoing scientific efforts to understand and monitor these volcanic activities are crucial for early detection and effective response to minimize the potential consequences of future eruptions.